In this lesson, we're going to talk about how to solve a system of equation that has a linear equation and a quadratic one. So before, when we solved systems of equations, it was just two linear ones, and we used like substitution, elimination, or graphing. So a similar idea, except now we have a quadratic. So first, we're going to look at this one. We want to know how many solutions are there. And so notice we have y equals x squared, which is a parabola, and y equals 2x, which is a line. So we're going to use Desmos to graph this right now. And I've already graphed it here. You can see them. And we can see that there are two solutions, okay? These intersect at two different points, okay? So our answer to this is, how many solutions does it have? Well, it has two solutions. And we even found out what they were. Hopefully I can remember it was 0, 0, and 2, 4. Okay, so those are points that work in both of those. Now, the question is, are there always two solutions? So let's go back to Desmos and change this. Okay, let's say let's not have a pencil, that's not helpful. 2x plus b, I'm going to add a slider here. Okay, and if we change that value of b, if we go this direction, see that we still intersect in 2 points, but then we can get to a point here where we only have one solution. Oh, there it is. And then if we change it some more, we can get to a point where we don't have any solutions. Okay, so linear and quadratic systems might have two solutions. They might have one, or they might not have any. So we're going to take a look at Desmos, and we're going to find the solutions to this system. Okay, we have y equals 3x squared and y equals 3x minus 2. So again, we have a parabola and a line. So come over to Desmos and get rid of these. We don't need those anymore. So here is 3x squared, and here is the line. Notice these don't intersect at all, okay? They're not going to intersect anywhere, even if you zoom out, okay? So for this, we'll say that there are no solutions. Now, Desmos is a great way to solve these, but we can also solve them algebraically, and honestly, that's what we tend to do a little bit more, especially in later classes. So when we want to solve these two things, remember when they were linear ones, we had elimination, substitution, and graphing. Really, with the quadratic linear, substitution is going to be the way to go. Okay, so we just want to use substitution to solve these. So what we want to do is we want to get our linear equation, we want to get that solved for one of the variables, y or x, it doesn't matter. So I'm going to solve this one for y. I'm going to start by subtracting 2x from both sides. So it gives me negative y equals negative 2x plus 3. And then I'm going to divide everything by negative 1. So it gives me y equals 2x minus 3. Okay, so now I've got the linear equation solved for y. I'm going to take all of this and plug it in for y over here. Okay, I'm just not come over here and do that. So I get 2x minus 3 equals 3x squared plus 3x minus 5. So now this is just another quadratic. To solve this, we're either going to have to use factoring or completing the square or square roots or the quadratic formula. Those are our choices. Let's get everything on the same side. So I'm going to subtract 2x, and I'm also going to add 3. I'm going to do those in the same step just to save space. So we get 0 equals 3x squared plus x minus 2. I'm kind of hoping that I can factor that. Let's see. Yep, it's factorable. Okay, so I'm going to factor this. I'm going to use umbrella factoring. 3x and 3x. See, the signs are different, and I get 6. I need factors of 6 to add up to 1, so that's going to be 3 and negative 2. And I'm going to divide this one by 3. So we get x plus 1, 3x minus 2. And I'm going to set those both equal to 0. I'm running out of little, space a little bit, and that's going to give me my two solutions. X equals negative 1, and x equals 2/3. Okay, so I have two solutions here. So that means that, remember, this was a parabola and a line over here. That means they intersect twice. One of the answers happens at negative 1 something, and the other one happens at 2/3 something. To find those y values, we just need to go back to one of the original equations to plug in. This looks like a great one. And I'm going to plug in -1, which gives me -5. I'm going to plug in 2/3. I might use my calculator for that. Gives me -5/3. Okay. So we can use substitution to solve these. If you want to check this on Desmos, you just pop both those equations in there and it'll give you your answer. All right. If you would like, you could pause the video here, do the try it on your own, and then just come back and watch it if you want to see if your solution is correct. I will walk you all the way through this one. So we're going to do the same thing here. We're going to use substitution to solve. So I'm going to solve this linear equation for y, because that looks easy. We get -y equals -2x plus 16. Divide everything by -1. And that's what we get. We're going to use substitution. So we're going to take all of that and plug it in for y up here. So we get 2x minus 16 equals 2x squared minus 6x minus 8. This is just a quadratic. We're going to hopefully factor it. If not, use quadratic formula. Either way, we need everything on the same side. So we get 2x squared minus 8x plus 8. That has a GCF. Let's get that GCF out that we can factor out of 2. And then we can keep factoring. I like it when we can factor things. Makes life easier. Looks like the signs are going to be the same, both negative. I need numbers that multiply to 4 and add up to -4, which is 2 and 2. I'm going to set all of these equal to 0. Now 2 can never equal 0. We don't have to worry about that. So x minus 2 equals 0 or x minus 2 equals 0. It's going to give me the same answer. And we get x equals 2. There's only one solution here. So if you went to Desmos and graphed these two things, this parabola and this line, they're only intersecting once. They're intersecting at the point 2 something. To find out that second point, you're going to plug into one of the original equations. This is a great choice. That's easy to plug into. So if you plug that in, you should get -12.